Hello everyone. Today we are going to start chapter 3 and name of this chapter is Aggregate, Water and Admixtures. So basically in this chapter we are going to details about aggregate. First about aggregate, that means properties, qualities, types of aggregate. Then next again details about water, that means properties of water, then what are the impurities what are affect the properties of concrete, and at last details about admixtures like types and influence of admixtures in the properties of concrete. So this is our chapter 3. This is the outline of this chapter. So first we are going to study details about aggregate. So let us discuss what is aggregate. Aggregates are the inert materials that are mixed in fixed proportions with a binding material to produce concrete. So aggregates are the inert materials, that means they cannot do any reaction with other materials which are present in the concrete mixture, and these are also act as filler material or volume increasing components on the one hand, and also are responsible for the strength, hardness and durability of the concrete on the other hand. And the importance of using the right type and quality of aggregate cannot be overemphasized. And the fine and coarse aggregates generally occupy 60% to 75% of the concrete volume. And if we consider by mass, then they contain 70% to 85% by mass, and strongly influence the concrete's freshly mixed properties, also hardened properties, mixed proportions, and also total economy of the structure. Next is qualities of aggregates. So here some important qualities of aggregate, like it should be chemically inert, that means they should not react with cement or any other aggregate or admixture or any other material what are present in concrete. Already I have told about it. And next, it should possess a sufficient hardness to resist scratching and abrasion in the hardened state. Next, it should possess a sufficient toughness to bear impact and vibratory loads. It should be strong enough to bear compressive and normal tensile loads in the ordinary mixture. And it should be free from impurities, inorganic or organic in nature material, which will affect adversely on its quality. And it should be capable of producing an easily workable plastic mixture on combining with cement and water. So these are some important qualities of aggregate. Next, let us discuss characteristics of aggregate. So the characteristics or properties of aggregates greatly influence the properties of concrete in the fresh stage, or it may in the hardened stage. In general, an aggregate to be used in concrete must be clean, hard, durable, inert, strong, properly shaped and well graded. And they should be free from different deleterious materials which results in physical and chemical changes in the concrete. And so let us discuss some properties of aggregate which must influence the properties of concrete, like particle size, that means size of aggregate, shape of aggregate, surface texture, specific gravity of aggregate, bulk density of aggregate, then surface moisture content, abrasion, porosity, bulking of aggregate, deleterious material in aggregate, soundness of aggregate, strength of aggregate. So these are some basic properties which will mostly affect the properties of fresh concrete, or it may be the properties of hardened concrete. So during the preparation we must have to take care of it. Next, fineness modulus of aggregate. So first is, what is fineness modulus? It is an empirical factor obtained by adding the cumulative percentage of aggregate retained on each of the standard ships ranging from 80 mm to 150 micron and dividing this sum by 100. After that we can find out the fineness modulus of aggregate. So this aggregate may be fine aggregate or coarse aggregate. In later we will again discuss about it. So next is, why to determine fineness modulus and why it is necessary or why it is important to determine fineness modulus of aggregate. It is generally used, or this fineness modulus whatever we calculate is generally used to get an idea of how coarse or fine the aggregate is. And the more fineness modulus value indicates that the aggregate is coarser, and small value of fineness modulus indicates that the aggregate is finer. And generally sand having fineness modulus more than 3.2 is not used for making good concrete, and fineness modulus can also be used to combine two aggregate to get the desirable grading. So we can determine the fineness modulus of coarse aggregate, also fine aggregate, differently. Next, let us discuss classification of aggregate. Aggregates are classified based on two things. One is, we can classify based on shape of aggregate, and another one is based on size of aggregate. So based on shape, again the aggregates are of following types, like rounded aggregate. Rounded aggregates are commonly shaped and available in the form of seashore gravel basically, and the rounded aggregates result in the minimum percentage of voids, that means 32 to 33%, hence gives more workability, and they also require lesser amount of water cement ratio. Next is irregular or partly rounded aggregates. These type of aggregates are partly shaped by attrition, and these are available in the form of peat, sands, and also in the form of gravel, and they may create a result 35 to 37% as void in concrete, and these will give lesser workability when compared to rounded aggregates. Next is angular aggregate. The angular aggregates consist well-defined edges formed at the interaction of roughly planar surfaces, and these are obtained by crushing the rocks. And again angular aggregates result maximum percentage of voids, hence gives less workability. They give 10% to 20% more compressive strength due to development of stronger aggregate mortar bond. Next is flaky aggregates. When the aggregate's thickness is small, if we compare it with width and length of that aggregate, it is said to be flaky aggregate. Next is elongated. Similarly, when the length of aggregate is larger than the other two dimensions, then it is called elongated aggregates. Next is flaky and elongated. That means what? Mixture of both flaky type and elongated type. When the aggregate's length is larger than its width and width is larger than its thickness, then only we can say it as flaky and elongated aggregate. This is generally obtained from the poorly crushed rocks. So these are the types of aggregates which are based on shape, and in next lecture again we will discuss about classification of aggregate based on size. So for this lecture this much. Thank you.